Welcome to Spring LIB.
Hi, let us consider problem of a piston. We have a point D which is in straight line with a point A, and at point D is a piston which is restricted to move vertically in a cylinder, and then from point D there is a rod ends at point B, and then point B is attached to point A, and this rod AB moves in a circle. It's called a crank, and so this crank moves in a circle, and that makes this piston D go up and down. So if this angle is theta, then the question asks what is omega of rod BD and what is velocity of piston D for theta equals 0 and theta equals 90 degrees. So let us look at each of these special cases. So for theta equals 0, we know that this rod is going to be straight, and what will be the velocity of point B? So point B is moving in a crank, right, in a circle. So the velocity of point B will be the radial velocity because of the crank AB. So this will be omega A times length of rod AB is B, length of rod BD is L. L is 160 millimeters, B is 60 millimeters, and omega A is 1000 rotations per minute. Okay, so this is going to be omega A times B, and then this is the velocity of point B. This is what the motion of point B is. But in a compound motion, we know that the motion can be broken into translation and rotation. So if this is the translational part, then all the points are going to have the same velocity. So point D will also be moving. This is the definition of rigid body with omega A B. And then plus, we need to add the rotational part. So for rotational part, let us assume B to be fixed. And then at point D, let us assume some omega. So let's assume clockwise. We had so omega is given to be clockwise. So even if you assumed wrong, if the motion was indeed or in fact counterclockwise, then if you assume clockwise motion, then you will get a negative number, which means that negative times clockwise is anti-clockwise. So it doesn't matter what omega you assume whatever you like. So if omega is like this, then the radial velocity here is going to be omega BD times L. And this translation plus rotation motion has to produce the net motion where point D is moving vertical and point B has this horizontal omega AB. Now by just looking at this diagram, we can figure out that for having there is no vertical motion possible. So first of all, VD has to be 0 because these velocities don't have any vertical components, right? So in this situation, for this theta, there is no vertical motion possible. Now about horizontal component has to be 0 because this piston is restricted to move only along vertical. So that means that omega A times B plus omega BD times L has to be 0. That means omega BD has to be omega A minus omega A times B divided by L. So this becomes minus 1000 rotations per minute clockwise. B is 60 millimeters and L is 160 millimeters, and rotations per minute are basically 2 pi radians per revolution, and then per minute is basically 60 seconds per minute. So minutes are basically 60 seconds, so minute gets away, then millimeters cancel, then revolution cancels, then 0 cancels 0, then 6 cancels 16 by 8, then this 0 cancels this 0, 2 can cancel this, so we get 3, and then 8 can cancel 100 by minus. Actually, yeah, so this will be 4, this will be minus 50. Okay, we have simplified it enough. We can simplify it further by minus 25 and then 2. So 25 pi by 6 radians. So it's minus 25 pi by 6 radians per second. So let's get this number. So, sorry, scroll too far. This is just an errant text. Okay. So let's do it without using calculator. By the way, pi can be approximated by 3, so you can just cancel 6, like 3 2s are 6, and so this number is going to be roughly minus 12.5. But let's get the correct number. So minus 25 times 3.14 divided by 6 radians per second, and then this gets further simplified. 2 3s are 6, then 1.57, then this 25 sevens are 175, so 5 17, 25 fives are 125, plus 17 is 142, then 2 14 carry, and then 25 1 is 21, plus 14 39 divided by 3 2. So this will be, as I said, close to 12.5, so this is 13.41 radians per second, and then the negative number, and then this was all clockwise because omega a was clockwise. So this basically tells you that omega bd is 13.41 radians per second counterclockwise. Okay, now let's look at case theta equals 90 degrees. So for theta equals 90 degrees, the rod BD, the rod AB is going to be flat, and A and D will be in straight line. So this is D, this is A, and the velocity of point B, if this is our rod, the velocity of point B is going to point directly downwards. So, and the value will be omega A times B. This is because it's clockwise motion, and the motion of B is coming from motion in a circle, and the motion in a circle is always along a tangent, and the direction is determined by whether it's clockwise or anti-clockwise. So for this, the direction is going to be this. So the same motion will be at point D because it's translational motion. By definition of rigid body, all points have the same velocity. Then if you write down the rotational motion part, assuming B fixed, so you will see that the velocity at point D is going to, so let's again assume it to be, so we figured out last time it was anti-clockwise, but anyways, let's just assume it to be clockwise again. So the velocity is going to point like this. The value will be omega bd L. Now here you can see that there is no way that you are going to have some horizontal component here, right? So you're going to have a horizontal component here, which will be omega bd L. If this angle is phi, then this angle is phi. This angle is 90 degree minus phi. So this will be omega b L L cos of 90 minus phi, which will be sine of phi. So, right. Now this component has to go to 0 because the net motion at point D is only along vertical. So what this tells you is that this is omega bd. What this tells you is that in this case, the omega BD has to be 0. So, and at point B, you just have your usual downward motion because of the circular motion of the crank, omega A times B. This is the net motion. So looking at these diagrams, as I said, you can clearly see that D has only a purely vertical component. There is no horizontal component because the translational velocity at point B is purely vertical because this angle is 90. Hence, there is no horizontal component to cancel this. So this tells you that omega BD L sine phi equals 0. And since sine phi is not 0 and L is not 0, you conclude that omega BD has to be 0 in this case. What about VD? VD will not be 0, but VD, as we can see from this diagram, is going to point downwards because this is the component which will give VD. So VD, rather than pointing up, it will point down. So VD will point down and the value will be omega A times B, which will be 1000 rotations per minute times 60 millimeters. This is 1000 times 6.28, which is 2 pi radians. So these many radians per 60 second times 60 millimeters. 60 cancels 60. So you get 6280 millimeters per second, which is 6.28 meters per second. So this is how you can solve for VD, and it's going to point downwards. So this much downwards, or minus J, or VD equals minus 6.28 meters per second J. Thanks. See you in the next problem. Bye.